When you solve this inequality, the first step you want to do, as you can see right here, is to distribute the negative 5 to both pieces right there. So negative 5 times x is negative 5x, and negative 5 times negative 4 is positive 20. And then over here on this side, I want to combine like terms. So when I combine 4x and negative x, I get 3x. So basically we're trying to simplify both sides. Now this side is simplified, here from orange to blue. This side can still simplify. I can still combine the 8 and the 20, giving me 28. So now both sides are simplified. So the next step in solving is to get the x's to one side. So I decided to move the x's to the left side. I always like to move my x's to the left side with inequalities. So the opposite of positive 3x is negative 3x, so I'm minusing 3x over. And a negative 5 minus 3x is negative 8x. Alright, then I want to get this 28 over, so the x is by itself, so the opposite of positive 28 is minusing 28, so you minus 28 to both sides. That cancels. And then negative 4 and a negative 28 added together is negative 32. Now to get rid of that negative 8 off the x, because you want x by itself, is you're going to divide both sides by negative 8. And once you divide both sides by negative 8, negative 32 divided by negative 8 is a positive 4. Now why did the inequality sign flip? Well, whenever you divide by a negative, it's a little rule you need to know, the sign flips. If you divide both sides or multiply both sides ever in solving by a negative, the sign will flip. So my answer is x is less than 4. Now, with these symbols, these inequality symbols, just look at these real quick, just a reminder. This symbol here is a less than. It looks like an L. That's how I always remember it. This right here is called a greater than. Okay, you kind of think of it as the end of the G, if you go whoosh, that little whoosh at the end. But as long as you remember that the less than looks like an L, the other one's a greater than. If you put this little line under the signs, it's an or equal to. So this one is less than or equal to, this one is greater than or equal to. Alright, now next we want to look at verifying our problem. So what we're going to do, in order to verify, what we're doing is we're going to choose a number that should be in true. So if I say x is less than 4, I choose a number less than 4. So I chose 1. You can choose any number as long as it's less than 4, and we're seeing if that number is true to see if we solved it right. So all I did is I took 1 and I plugged it in for all the x values. Alright, so right here where the 1, 1, and 1 are, were x's. So we replaced all the x's with 1. And then I do order of operations. So I do the math inside of there. 1 minus 4 is negative 3. I do the math right there, get 4. Next, order of operations, what I'm going to do next is I'm going to do some multiply on the left side. So negative 5 times negative 3 is 15. There's no multiply or divide here, so I'm going to subtract these two, giving me 0. Because you add, subtract left to right, just in case, to remind you. Okay, now here in the red, so now we've got to simplify each side still. So 8 plus 15 is 23, and 0 minus 1 is negative 1. And is 23 greater than negative 1? That is true. So I just verify that 1 is an answer, and 1 is less than 4. So let's also check a value that should not work. So I chose 5, because 5 is greater than 4, so this should not work. This should not be possible. So I'm going to plug in 5 and see what happens. So just like before, I put 1s in for all the x's, and now I'm putting 5 for all the x's. Do the math there, that's 1. Do that, you get 20. So I need to multiply over here. So that gives me 5. And then I left the 8, just bringing the 8 down. Here I take 20 minus 4 is 16, bringing the 5, negative 5 down. Simplify this, that's 3. Simplify this, I get 11. And is 3 greater than 11? No, that's false. So that verified that the 5 does not work, but the 1 does. If I were to try to find any value less than 4, say I could plug in 2, 3, negative 8, all those should be possible, should get a true statement. But if I choose any value that's bigger than 4, because it's not part of the answer, like 5, 6, 7, 8, 9, they would all come out to be false. That's what verifying means.